We're talking about chapter 3, section 3, how derivatives affect the shape of a graph, and we're going to be looking at question 34 that has 4 parts. The first part, part A, says find the intervals of increase or decrease. Part B says find the local max and the local min. C says find the intervals of concavity and the inflection points. And D basically asks you to to sketch the graph and then check your work using a graphing calculator or whatever you want. So it's basically the same as the previous video that I did, but in this case they're asking you to graph it too. So let's look at part A first. So we're gonna want to take the derivative, right? Because we want to know when it's equal to 0, and therefore then we can actually work out what the absolute max and mins are gonna be. So let's take the derivative. It's gonna be 36 plus 6x minus 6x squared. Okay, so to find the critical points, we want to equal this to 0. We want to know when the slope is 0. Notice that we can take, I'm going to take a negative 6 out of this. That's going to be equal to x squared plus, minus x minus 2. Is that going to be right? No, minus 6. Yes. Okay, notice that we can factor this out as x minus 3, x plus 2. Therefore, our critical points are going to be x equals 3 and x equals negative 2. Okay, so remember that we have to draw a number line and kind of see when our values are going to be negative and positive. That's going to give us how the slope changes. It's going to give us when it's increasing and when it's decreasing. So we're going to plug in numbers to our f prime of x. I'm going to pick a number that's less than negative 2, say negative 3. And I'm going to use a calculator real quick to actually calculate this. So it's going to be this is going to be negative 36. Then I'm going to pick a number between negative 2 and 3. I'm going to pick 0 because it's easy. So you have 36 plus 0 is just 36. It's going to be positive. And then let me pick a number that's greater than 3. I'm going to pick 4. So it's going to be 36 plus 24 minus. It's going to be negative 36. Oh, look at that. Okay. So it's going to be negative. So our answer is going to be, well, it's increasing on the interval negative 2 to 3, right? So we're going to write negative 2 to 3. And then it's decreasing on the interval negative infinity to negative 2. And then union 3 to infinity. These two. Okay, so this is going to be your answer for part A. We're going to move on to part B. So part B is talking about it's talking about local maxes and mins. Let me reread what it said. Find the local max and min values. Okay, so we already have the derivative when we already have the x points where the derivative is 0, which are the critical points. We already found those. So we just want to know if these are going to be local maxes or mins. Basically, when the derivative is 0, those points are going to be the ones that we want to look at to find relative max and mins, local maxes and mins. If you look at the number line again, we see that the slope here is going down and then up, and here it's going up and then down. So just by looking at this picture, we can tell that the local max is going to be 3. It's going to be f of 3. We can actually calculate this if we plug it into our original equation, which is up here. So we would want to do 36 times 3. So it would be 36 times 3 plus 3 times 3 squared, and then minus 2 times 3 cubed. That's going to give us 81. That's going to be our local max. And then our local min is going to be f of negative 2, which if we plug it in our calculator, let's see. We would have 36 times negative 2 plus 3 times negative 2 squared, which is 4, minus 2 times negative 2 to the third. It's going to be negative 44. Is that right? Yeah, okay. I was just checking if I did this correctly or not. I think I did. This is going to be our local max and local min. Just by looking at our number line. Okay. Let's move on to part C, which is asking us, find the intervals of concavity and the inflection points. Remember, when you hear concavity, you just have to take the second derivative. That's all you need to do. So let's do that. We're going to take the derivative of f prime, which is right here. So it's going to be 6 minus 12x. And we want to know the inflection points, or the points of inflection, are going to be found by equaling the second derivative to 0. So if we do that, then we know, okay, so we add 12x on both sides. It's going to give us that x equals 6 over 12, which is just 1/2. That's going to be our inflection point, our point of inflection. And we need to find how the concavity changes, right? So let's draw another number line right here. I'm going to remind ourselves that we're looking at f prime prime. I'm just going to put in our only inflection point. And now we're going to evaluate at that, we're going to evaluate on the second derivative. A number that's less than 1/2, I'm going to pick 0. So it's going to be 6 minus 0, which is just 6. It's going to be positive here. And then I'm going to pick a number that's greater than 1/2. I'm going to pick 1. It's going to be 6 minus 12 times 1. So it's going to be negative 6. So we're going to have a negative here. Okay, so we have our point of inflection, which is going to be x equals 1/2. And we now know it's going to be concave up from negative infinity to 1/2. And it's going to be concave down from 1/2 to positive infinity. For part D, I'm going to start by, we have to sketch the graph, right? I'm going to start by just drawing some axes here and here. And we already know a few points that are important. From part A, we know that the critical points are going to be x equals 3 and x equals negative 2. And in part B, we actually calculated them. So let's plot those points. So it's going to be negative 2, negative 44. Let's pretend this is negative 44. And then we also have that f of 3 equals 81. So let's pretend this is 81. Okay. We also know that, we also know the inflection point is going to be 1/2. So, it's going to be somewhere in the middle. I'm not going to draw that one yet. Well, we kind of have to see where this graph crosses the x-axis, right? That's what we want to know. That's going to be easier to draw. It's going to be easier to draw this if we know where it crosses. So let's calculate that. okay. So now we have to equal this to 0, right? I can tell that I can take 1x out. We can factor that. And I cannot factor this any further. I would have to use the quadratic formula to solve this. But just by looking at this, we already know that x equals 0 is going to be an answer. So let me just write that in. It's going to be x equals 0. And then by using the quadratic formula, I'm not going to do it because I calculated it before. But if you use the quadratic formula, we get x equals 3/4 minus 3 square root of 33 over 4. And then the other one is going to be the plus. That doesn't look very helpful. So let's actually calculate them in actual numbers. It's going to be 5.06 more or less. And for the negative, it's going to be about negative 3.56 more or less. Okay, so we have x equals 0, x equals about 5, and x equals about 3.5. So let me just, okay, it's gonna be negative 3. So our roots, where the function crosses the x-axis, they're gonna be about here, more or less, and about here, more or less. So we kind of already know what it's gonna look like. Well, we know that the graph is gonna decrease from part A. We know that it's gonna decrease from negative infinity to negative 2. So we know that a graph is gonna look like this. And then we know there's a change to positive, and then that's gonna be your maximum, and then it goes down. Now notice we also have to talk about concavity. Well, it's going to be positive concavity from negative infinity to 1/2, and then a negative concavity. So let me actually redraw this a little bit so that you can see the change a bit better. So at about here, there's going to be a change in concavity. All this is positive concavity, and then it switches to negative. I know it's not very pretty, but just imagine it's perfect. So right here, that's going to be your inflection point. That's going to be it. Just label. I'm going to do x. F of x. This is going to be your actual function. Let me erase that. Okay. And that's it. You're done.